All right. Anyway, we'll get started, okay? I cannot find her.
All right, sounds good.
Okay, number one, we have a website class. This is for in
Yeah.
the Moodle. This one's the CS41C programming.
Yeah.
We will teach C language for 8 weeks,
Okay.
okay, and then C double plus after that. And we have C double plus 1, 2, 3. How far can you go? I don't know, because depend on your time, okay?
Yeah.
So, but one thing is that number one, must arrive class on time, okay? Don't be late. Late is not
Okay.
good. Second, must submit homework,
Okay.
okay? Because if you don't work on homework, you're not going to learn anything. Third one, we do not have coding practice time, so you need to work on this one, the solo learn
So, okay.
introduction to C by yourself.
Okay.
Okay, so this one is the practice side. I want you to get started.
Yeah. Okay.
And you need to monitor by yourself. We don't have a coding back practice time.
Okay.
Okay, so this one I post it here. Another one is you may need extra practice problems. Our homework is just very minimum. So the extra practice problem, you can find it from here, W3 source.
Okay. All right.
So you go to this W3 source, this one, there is a program section for C language.
Okay.
There are more problems than you need. So you actually jump from problem to problem. Then they also have the solution, so you can actually look at it. So we don't offer
Yeah.
the needed problem. So here that's conditional statement. There are 130 problems. Okay, but you don't need to work on
Okay.
all. You don't need to work on. You don't need to reply all the time. I just need you to understand it. Okay, so
Yeah.
here are a lot of problems, and then you need to work on them, jumping from one problem to another. But you need to work enough problems, maybe each chapter 20 problems by yourself. Not every one, but you need to do enough ones. So here we have plenty of the problem for you to practice. Okay,
Okay.
so this one is the practice site. And textbook, we have a C programming guide. This one is a PDF you can download. This one is a very good C programming language course, beginner's book. Okay, so you can download this PDF. And then there's another one called How to Program C. Okay, later there's a How to Program C double plus. Here again is another PDF file you can download. Okay.
Yeah. Okay.
So this one is another book that you can download anyway. So here are different textbooks, but you need to study it by yourself. Okay.
Yeah.
So now let's get started for the course. Since you are not new in computer science, so we'll get started
Okay.
for this course.
Yeah.
So first chapter, introduction. So actually, there is a very famous textbook. It was used for a long time, since 1970.
Oh.
It's called the C programming language. In fact, in college, when I was in college in 1986, my freshman year, our
Yeah.
introduction to programming, we are on C language. So we are using this textbook from that time.
Yeah.
This is a very famous C language programming
Okay.
course. Okay, you don't need to reply. You just need to listen. Okay.
Yeah. Okay.
You actually keep talking. I may got interrupted.
Okay. All right.
Yeah, but you need to when I ask question, you need to answer, or you have question, you can answer, but you do not need to nod all the time because it will interrupt me. Okay. Okay, so the C language, this one is we are talking about the introduction to C language. You will cover the data type, operator, basic I/O, okay, conditional expression, control flow, loops, functions, program structure, recursion, pointer, and array. The most important part that you want to learn C++ is this pointer and array. Okay, these are new. In Java, you don't have this. Others are not much different from Java. Okay, but the most important part you want to learn is this one. Another thing is the structure and union. This one is also new. You also want to learn it. And then dynamic allocation. This one is also new. These three topics are new, not the same as Java. Okay, storage class is different topics. Okay. And then why we need to study C language? Okay, we have a standardized the ANSI language in 1989. So when I was in college in 1986, before that, this language invented in 1970. So basically, there are a certain time there's no standard. So C language is very bizarre, very messy because at the early days, C language don't have any standard. So in 1989, there's a first version being standardized. We call it C89. Okay. And nowadays, it keep moving. There C99, C2003, C2007, C11, C14, C17, C20, C23. These are different versions of the C. This one is before 2011. Okay, this one is C 2014. Each version, there are some improvements, so the grammar is slightly different. Okay, so you need to remember that these are different one. And C double plus is extension to C. It was originally called C with object. Okay, but later it changed the name to C double plus. Okay, anyway, but you need to learn C before you go to C double plus. So these are the development's history. Okay, you can search the internet for it. So I don't repeat it. So basically you have 98 version. Actually before that there's an 89 version, 98, 03, 11, 14, 17. Okay. When you go to the competition, it actually had this different version. You need to know what are added there, but it can be used. Okay, so that's actually the history. And then why we need to learn C language, that's because that when a CPU was designed, let's assume that you have a CPU, and this CPU is x86 architecture. So your CPU is like here. On top of the CPU, the first compiler being used will be C language compiler. So you will have C language compiler and assembler working first. And based on these two languages, usually you develop the so-called operation system. So you build the operation system right there, maybe Unix, maybe Linux, maybe Windows. Okay. And on top of it, you design the C++ compiler. And then based on C++, you develop your Java compiler, your Python compiler, and different kind of compiler, and then you develop all the software on top of it. So in a way, C and assembly is very essential course. That's the first hardware-related language.
Yeah.
You want to learn them because you want to learn hardware, and then you want to actually know about how to program in the CPU. Okay, that's the purpose. And then if you go to UC Berkeley, okay, UC Berkeley have CS61A for Python, 61B for Java, and then there's a 61C. This is C, actually it's the C language plus assembly. So many college will require C as a very essential language. So if you go to Irvine, say UC Irvine, Each year has the ICS 51 that is on C plus assembly as well. So many engineering type computer science course, they do have the C language in their early course. Okay, anyway,
Yeah.
that's actually what I want to cover. Okay, that actually is why it is important. Now we are going to work on a C program. Okay, so C program, before we go for a C program, you must know about there are many libraries. There are many libraries. So library are the code that people have written for you. And then you need to call those library in order to run. So it's similar to Java. When you have a Java, you have the import java.util scanner, those kind of things. Okay. But right here, we do have a library you need to encode. And then program start with the integer main, okay, and integer list. We'll talk about it now. Let's get started, okay? So there is an integer main void, integer count, integer argument vector, integer vector, and integer environment parameter. Okay, this different type of the this different type of program header. So let's get started for one program. So to write a program, you actually get started with your editor. So let's actually bring up Visual Studio Code.
Okay.
So this one I'm going to close, and then here I'm going to open the folder. So let's see, we go to our E drive and then go to here, go to C double plus. Okay, so right here I'm going to do creating one. This one I'm going to do CS41, okay, C language. Inside here, I'm going to create another directory that's called C dev, C development environment. Okay, so C dev. So inside C dev, we are going to create a first program. So let's call it chapter 1. Okay, so inside the chapter 1, we actually select a folder. Now we are going to create a program, and then here we will have the first program, let's call it hello.c. Okay. So inside this hello.c, we'll get started for the program. So let's actually close this one. So inside this hello.c, we are going to do first include stdio.h. This one is command, double slash is command. This actually is include the standard IO. Okay, standard IO means input and output. Okay, so basically we need that. And after that, we actually do integer main. Here we can put void. Okay, void means nothing, no parameter. At the end, we do return, we put a 0. 0 means x equal 0. That means no error. Okay, that means no error.
Yeah.
And then here we do one thing, we do print that this is formatted print. Okay, print app. So formatted print as print hello world. Okay, that's it. We may need to use a /n because we don't want to change line. So we actually put a /n. And we finish because I installed a code runner already. So here it has a code runner. I installed a code runner already. So right here, I can right click and run code. And you'll get hello world. That's one way we compile it, okay?
Yeah.
But that's not the regular way we do it. So we bring up the terminal. So right here we do GCC. Okay, GCC is the C compiler. It's GNU C compiler. Okay, it means GNU C compiler.
Yeah.
So GCC is GNU C compiler. And then we have this one called hello.c. Okay, you compile this hello.c. HO means output file. Your output executable file. Your output executable file would be hello. Okay, so let's do dir. There will be a hello.c and hello.exe. So hello.exe is the one that we created by this one. That's your executable file, and then you will run it hello. And
Okay.
you work for it. Okay, so this one is the first program we will write. Okay.
Yeah.
Now let's look at the second program. Okay, so let's actually work on here. Let's actually work on another program that's called welcome. That's C. Okay, welcome to C. So this welcome to C, let's repeat it again. It's actually you need to do include stdio.h int. Okay, main program. Now right here, you can put void. You can also put integer C, integer argument C, integer no character star argument vector bracket. Okay, these two. And then here we also do return 0. Now, here we have two things. You have integer argument C, it's argument count. Okay, you have character star argument vector bracket. This is an array of character pointers, which means array of strings. Okay, so anyway, here we do have the argument count and we have the argument vector, and we will get two variable, and then let's do this. Let's do for integer I equals 0, I less than argument count, I increase. Okay, and then we do print at percentage s slash s argument vector of I. Okay, what this means is here we do have array of strings. So each one of them, we are going to print it out. And then there's an argument vector. Argument vector means argument count. That's a counter of the arguments. You will know about how many arguments are there. Okay, so now let's save this one. I will run it and you will know what it is. So this one, that's actually to dir. Now there's a welcome to C. So we do GCC welcome. HO welcome. I'm sorry, welcome need to be have a C and then HO welcome. So after finish, you already got a welcome.exe file. Then at this moment, you do welcome A, B, C, D, E, F, G. So welcome that this one is argument 0, argument 1, 2, 3, 4, 5, 6, 7. So totally 8 arguments. So you actually go for I from 0 to 8, less than 8. Each one of the argument vector being printed. So you print out vector 0, that's welcome, vector 1, that's 8, okay, to vector G. Vector 7, that's G. Is that okay so far?
Yeah, I mean, so wait, why is welcome being considered a like I guess like why is welcome being considered as an argument here? Isn't that us calling the program? Why is it being considered a
That's
variable?
argument zero. That's argument zero.
But I mean, isn't that calling the program though? Or is it doing both?
That's the definition of argument vector.
Oh, okay. Okay. All right.
Okay, that's
Yeah.
a definition of the argument vector. So right here we do what we want to tell you is that the program has two main program style, integer void and integer argument count and argument vector. There's a third one that actually is integer argument count, argument vector, and environment parameters. Okay.
Yeah.
That one actually we don't talk about it right here. Okay, it's more advanced C programming.
Yeah.
So we up to here we talk about the style. By in system program we will kind of need it, okay, but not right now. That's actually stop right there. So now that's actually when we have the main program, that's actually how you write your main program, okay? Okay, so GNU is not Unix, actually is GNU, okay, and we use the minimum GW version of the GCC, so it's a min GW64.
Yeah.
And GNU C, okay, C is a non-portable, so each machine need to have different compiler, okay? Okay, so this one we used to teach using Eclipse, C double plus or Cobra, but nowadays we don't support it. We actually work on Visual Studio Code. Okay, so first one we actually compile already. So this one, okay. Remember you have stdio you need to include, and you need to use bracket right here, okay?
Yeah.
Okay, the compilation status. First, you will have the .c file, that's your program file. And then you will compile to object file, that's actually .o file. And then you link together to create a .exe file to run, okay? So this one, let me actually redo it one more time. That's actually redo it. Instead of running the GCC, this one, let's actually do it. Okay, so right here, I'm going to delete welcome.exe. Okay, suppose that there's no compilation, okay? Because we deleted and then we dir, there's no welcome.exe anymore. So now we are going to do GCC-C actually welcome.c. So you dir again that one file called object file welcome that O is created. Okay, using you use the GCC -c. -c means compile only. Compile only, you compile only the welcome, so you do not link it. You do not create an exe file. You only create it to the object file. So right here, it actually only create a .o file. That's actually welcome.o. After that, you need to link it to create an executable file. So we do gcc, okay. Then we have welcome.o -o welcome. That will link the dash welcome.o to a welcome.exe. Okay, and then with dir, then the exe file being created. So in a way, you have a C program. You may have multiple C programs. Each one of them create a .o file. And later the linker put them together into one .exe file. Okay, so this is how a bigger C program is created. But right now, it's just only one file. Okay, so only one file, we usually directly compile it instead of linking them together. But later, when you go to bigger project, you may see that. Okay, you may see that. Okay, so this is the whole compile process of the C language. Okay, and then this directory permission, you have 10 digit, you have D, R, W, X, R, W, X, R, W, X. This is in Linux. D means directory. So D, you have D, the directory. RWX is run, read, write, and executable. So read, write, executable for user. This first three is user. Second one is your group. Third one is public, everyone. So here it talk about the read, write, executable write for each file. Okay, in Linux, you need to know that. But in Windows, you don't have that. Okay, so right here we are talking about Linux system. So file, they will be dash. There's no D is directory. Okay. But you need to know that when you do Linux system. So we have special file. That A is the static library. That SO, that's a share object code. That O is object code. So we do show you the object code, okay? And then that .exe is executable file. These are the standard name you didn't know. That C is the source code, okay? It's different file extension you need to know in C language. Okay, we have this GNU C, GCC, okay? And then we show you how to do GCC to compile it already. So this one we don't repeat. Okay, so this part is our chapter 1, okay? And variable name, not too short, not too long. Usually, you only remember 31 characters. Too long, it will be ignored, okay? And you will start with later, and then capitalize lowercase and digit and underline is okay, okay, in the variable name.
Yeah.
So only later digit and underscore, these are the variable name, and then you can only start with the A to Z letters and underscore only. You cannot start with 1A, that's actually not okay. A1 is okay. And there are some reader word. Okay, and then, okay, anyway, these are the requirement for the variable name. So here we have a mathematical program. That's actually work on a mathematical program. So we are going to do number 1. This one is called addition. The name is wrong. Let me rename it. It's called addition by C. Okay. So right here we are going to do include. Okay. stdio stdio.h, and then integer main. Okay. Remember here is integer argument count character star argument vector. Okay, and here we will return 0. So this is the program structure that we created first. Then we may have integer a equals 3, integer b equals 4, integer c equals a plus b. Let's have the printf. Printf is similar to system.out.printf. In fact, Java is learning from C languages. So, but here you do not need to have the system.out. It's just printf. Right here, you do have actually percentage d plus percentage d equals percentage d \n. You put your A, B, C there. That's it. That's actually one mathematical program for addition. So finish that, we do the IR right here, it's okay. So we do GCC addition, -C-O addition. And then we do addition. you get 3 plus 4 equals 7. Any questions so far?
No.
Okay, so this one is a program that take two numbers and sum them together and print out. Okay.
Yeah.
Now next one we are going to do one more. This one is called it addition to the C. So this addition to the C, let's say to copy the addition to C over, put it over here. Okay, now we do declare A, declare B, okay. But at this moment, we actually don't assign number to it yet. So we do scan, okay, let's do this, let's do printf A equals, then we do scan F. Scan F is like scanner in the input, okay. So right here we say percentage B, okay, is digital. And then alias A, okay. You have to put the ages at before A, then you will scan in value to A. Okay, this one later we talk about why here need to be a star, but not right now. But right now, you just remember you need to write it this way, and then we do pulling the L B equals something scan formatted scan. This one means formatted scan. So right here we have formatted scan, and then we do percentage B alias B. Okay, so we do read in formatted scan for A, formatted scan for B, and you calculate C. Okay, this is our addition number 2. So read in two variables, sum them together and print out. So this one is do C addition to the C threshold addition to. So we run addition to A equals 3, B equals 4. Any questions so far?
No.
So this one so far we are printing now, getting into variables, getting into variable, and then print it out. Okay, so this one is another arithmetic program that we use for here. Okay.
Yeah.
Okay. And then slash is comment, is the same with Java. Slash star slash, that's also comment, block comment. These are the same as Java. Okay, it's a good habit you need to know anyway. So you create and then build and then create. Okay, it's okay. Now we finish chapter 1. Okay.
Okay.
Chapter 1 is pretty simple, pretty short. Let's go to chapter 2. We have more chapter than weeks. So that means that we only will go for one chapter a week. Okay. We will actually depending on our progress.
Yeah.
Maybe 1, maybe 2, maybe only half of the chapter, but we have 13 chapters right here. We try to cover 10 chapters maybe, but we try to go a little bit faster right here. Okay. So chapter 1 is very short. Now let's go to chapter 2. Chapter 2 is the elementary programming data type operators, those kind of things. So tokens and C language, you have int, char, float, double, boolean. These are different types. So bool is boolean. Okay, it's different from Java. So here this one is boolean. These different type char, float, double, these are all in the same, similar in in Java, but a little bit different. The char is a bit. Assigned a bit. And then in JavaScript, in C is signed a bit. In Java is unsigned 16-bit.
Yeah.
So these are different. Okay, these are different. Floating point 32-bit double, I think is 48-bit, but it's a double. Okay, it's a double type. So the data type we'll talk about it later, but here we have different double type, and there is the compound type for array structure. And then you need to know about assignment. You need to know about punctuation, pointers, operators. So these are different language feature. We'll cover it. Okay, we'll cover it. So there are keywords, constant, identifiers, strings, special symbols, and operator. These are all tokens in C language. Token means words. So tokens in C language, okay, the naming convention, we already talked about it, so I don't repeat it one more time.
Yeah.
Okay, these are simple parts. Keyword, these are different keywords. Remember, these different keyword you cannot use for the variable name, okay?
Okay.
So now next one is data type. Data type, you need to do integer and count. This is the same as Java, but Java usually require you to assign it with 0 if you are in the function. So right here, you don't need that, but if you don't do that, you will default give you a 0 in there. Okay, but usually we want you to initialize to 0. That would be safer. Okay. So we have integer, double, or whatever. Okay. Character still be single quote. Okay, character still be single quote. Okay, this part is okay, not hard. So there are several different data type: integer, character, floating point, and double type. Okay, and there is also a Boolean type. Okay. Now one problem right here is you do have an integer, but before integer, you also have the long, short modifier. Before long short, there is another word called unsigned and the signed. So signed, you write it or don't write it is the same. You will actually get signed number. But you actually may have a declaration of unsigned long integer, unsigned short integer, signed long integer, signed short integer. And as for how many there are, different compiler may come up with different numbers. So int maybe 4 bytes, short maybe 2 bytes, long integer maybe 4 bytes, but there is another number called long integer that actually is 8 bytes. So long integer and long integer is the same. So let's look at this one. A little bit bizarre because in the old day, the C language had different standard. So right here, let's call it data types. Let's see. So right here, you can declare integer a equals 3. You can declare a long integer b equals 4. You can declare a long integer c equals 100 is. So this one is 8 bytes, 64 bits. This one may be 32 bits, 4 bytes. This one, 32 bits, 4 bytes. But sometimes only 2 bytes. 16 bits. Okay, some machine do that. Okay. Some machine do that, but nowadays, because computer already bigger, so I think integer always 32 bit. But if you want to have a 64 bit, it's long integer, it's not integer. So here let's do print we print out A and B, both of them are percentage D. Okay. This one is more difficult. It's called C. It will be long D. Okay. For C, because this one is long integer. So long integer, when you do printf, long integer, when you printf, you have to use different format. It's called long D, it's not D. Okay?
Yeah.
So this one called GCC data types. Let's see, O data type. And that's long data types. Okay? So these are different data types. We print now. Okay, so that's different data type. So data type do matter a lot. And they are long double, long double. Okay. Long double is 8 bytes, but there's a long double for 128 bytes a bit as well. Anyway, here we have 8-bit number system. So it actually is using the so-called two's complement system. Okay. So two's complement system, you have 0, you go to 127. You have -1, that's 1111, go to the negative. Okay. So these are the negative x. We use the two's complement system. Okay. This one, because you did not take the AP course from me, so I'm going to talk about it again one more time, since
Yeah.
you don't know it. And this one is very important when you go to assembly, so you need that. So let's bring out the AP computer science slides. So we are going to talk about two's complement. So first, the number we are using has the number system. We have a digit and value. Okay, this one, okay. And then you have different digit, decimal point, and place. You have binary numbers, okay. You have binary number, that's okay. So the number system, you have decimal, binary, octal, and hexadecimal. It's okay, I think it's part okay. Binary number, you represent your binary number using successive division to get your binary representation. And then you convert back from a binary number to a decimal, okay? I'm assuming you know both of these. Okay, anyway, that's actually subtable you need to understand. But now if the integer type, we are using 2's complement. So what is 2's complement? So because you have, so let's assume this is a 4-bit system. 4-bit system, the smallest number is 0, 0, 0, 0. Largest number is 1, 1, 1, 1, since you have 4-bit. But it represents 0 to 15. But there is no -3, there's no negative number. So we don't use this, this one is called magnitude. Magnitude is only the size of the number. So we do not use this magnitude system, we use the 2's complement. So 2's complement means that we cut the number space in half. If you start with 1, the digit start with 1, we consider to be the negative number. And then starting with 0, we consider it's positive number. So how to represent a number that's negative? Let's assume that we have a number 5. So number 5 is actually 0, 1, 0, 1. And we want to represent -5. So -5 is defined, -5 is defined as 2 to the power 4 minus x, since we are using 4-bit system. So here is 4 minus x. So right here, 2 to the power 4 is 16 minus 5. So we will use 11 to represent -5. So 11 is 1, 0, 1, 1. That is your -5. So your 5 is 0, 1, 0, 1 plus 1, 0, 1, 0. You got 0, carry 1, 0, carry 1, 0, carry 1, 0, carry 1, carry. So we create an overflow bit that we will dump it, and the remainder number will be 0. So your x plus minus x will be equal to 0. So that's why we use the 2's complement number as the negative part. Any questions so far?
No. No questions.
So let's assume that we have a number called 3. Then which number we pick for -3? If we are using 4-bit system. Hello?
I'm looking at it right now. So 4 bits. It's like zeros. Not really sure, to be honest. It's
I just finished it and you say you have no question, right? Next time, please go back home to sit in front of computer to study, okay? You
Yeah.
can't do it by this remote using cell phone. This is making no sense. It's you just try to belittle my course.
Yeah, okay.
It makes no sense, okay? Complete no sense. You are not learning in this way. And C is or C double plus is not as easy as Java. I know you try to attend this course, but it doesn't work. Okay.
Yeah, no.
So 2 to the power 4 is 16. You minus 3. You will use actually, I'm sorry, you use -3. Let's see, you will use a 13 for it. So 13 is 1, let's see, 1, 0, 1. So these two you sum together will be 0, carry 1, 0, carry 1, 0, carry 1, 0, carry 1. It have a overflow bit, and the remaining bit would be 0. So you dump this bit, you got a 0. So we use 13 as the negative part. So why this is so important? So you learn all the assembly, you learn all the C language, you learn all the hardware. You all need to know what's two's complement. C language is the same. You all need to know about it. Okay.
Yeah.
Anyway, I try to give you the idea of what's two's complement. That's the number that we use for signed integer. So if we do have an unsigned integer, and that's assume this is 4-bit, then this unsigned integer will start from 0, 0, 0 to 1, 1, 1, 1. So it's 0 to 15. If it is unsigned integer. If it is signed, then it's from 0, 0, 0, 0 to 0, 1, 1, 1. This represents 7. So from 0 to 7. And then negative, you have 1, 1, 1, 1 down to 1, 0, 0, 0. That's actually negative 8. So sign number is from -8 to -7, to positive 7. And then unsigned from 0 to 15. It actually have different interpretation on the same number representation. So your 1111 is interpreted as -1 is signed number. 1111 will be interpreted as unsigned integer as 15. Okay, that's how the hardware work. Okay, anyway. These are two complement. And then there's a float, there's a double and long double. Okay, low double, you see some machines 8 bytes, some is 12, 10 bytes. And there's another one called long double. That would be actually that would be 12 bytes. But anyway, these number, how many bytes? You really don't know because different standard, they have different lengths. So a better way to know it is you check internet. So you say let's call C11 data type length. That will tell you what is defined in C11. Okay, so here long show whatever. But if you want to have the C17 version, you check C17's data type version. Okay, so they may give you different number, but you have to check which one you use. So let's go back to our program. So here, let's assume that previously we just do compile. So when you do compile, you use a C98 to compile for you. Now, if I want to use a different standard, let me use a GCC dash. Let's see. STD equals C11. Then this one is assigned the standard to be C11. And then you do data types, let's see, HO data type 2. Okay, I'm going to use this. So by doing this, you will compile the data type 2 to the C11 2011 version. But now you may have GCC STD equals C17. Then this one is the 2017 version of the C language. You do data types at CHO data types. 3. You type the data types 3. Okay, so what I want to say is that you do minus std
And then
equals the version, okay?
Yeah.
Gnu support different versions, but which one is how long, I don't know. I really don't know because I never remember it. It's too complicated because of the history.
Yeah.
Okay. Okay, and then we have, again, there's a signed and unsigned. Signed is using the two's complement system. Unsigned, so it's the range is minus 2 to the power 7 to 2 to the power 7 minus 1. And then if your sign number is actually from 0 to 2 to the power 8 minus 1. So these two, the range is different.
Yeah.
And unsigned has no integer. No negative part. Okay. Okay, then there's ASCII code. This is a character. Okay, character following the ASCII code. 2 byte, 1 byte ASCII code. Okay, no problem. And then there's a std bool that is Boolean type. So if you don't include this one, there's no Boolean type. Okay, there's no Boolean type. So Boolean type, okay, let's talk about Boolean type. Boolean type, let's see. Let's create number one. Let's call it Boolean number one. Let's see. So here I'm going to create stdio dash integer name boy then 0. So let's do here. Let's actually do integer a. Okay. And then let's do print f a equals. Let's do scan f percentage d. Okay. And then here we in a. So you need to do h as a. Okay. So this one will read in a number for a now. So if a print f a is non-zero and is Boolean true. Okay. Else print f a is 0 and is Boolean false. Okay, this is very important in C language. Okay. C language in principle, there's no Boolean variable, only using integer. So when the number that's not zero, it is a true. If it's 0, that means false. So let's do this experiment. So save, let's do GCC Boolean 1. Let's see, okay, HO Boolean 1. So now we run Boolean 1, and then let's put in 0. So we print out a 0 and the Boolean false. So that means that you put a 0 right here, you consider to be false, and you print out Boolean false. Let's actually run it one more time. So Boolean 1, you put in 1, and you say a is non-zero and Boolean true. Let's run one more time. Boolean 1. Let's put in 100. 100 is also non-zero, is also Boolean 1. So in C language, 0 means false.
And then 1 means true.
Non-zero, not 1. Non-zero means true. Anything not 0. So you have 0, 0, 0, 1, that's 1. 0, 0, 1, 0, that's also true. Both are true. As long as it's not 0, it's true.
Yeah.
Any question?
No.
But there is no extra Boolean type needed. Okay. So let's actually copy this from Boolean 1 to another program. Let's call it Boolean 2. So in this Boolean 2, okay, we actually have this, we try to use this one called include std bool h. This one called standard Boolean. Okay. Standard Boolean.h. So in this standard Boolean.h, we do have a, let's call it bool. Instead of, well, you call it bool, standard bool. So in memory, it still is an integer.
Yeah.
There's actually no difference. Just give you a different name. So let's just say this one and run it again. So this one called TCC Boolean 2, that's CHO Boolean 2. And then you run Boolean 2. So let's put a 0. It's still give you the 0. Okay. You read in 1, it should give you non-zero. Okay. Any questions so far?
No.
So this standard bool.h, you include it or not. The only difference is that you will have the bool type you can use, but bool type in principle is still is a integer, not much different from the integer. But C language try to create a new type called Boolean, and it's added in 99 version. So 89 don't have it. Okay, that's what it is.
So most people don't choose to use std bool. They just put in the methods that we used, I guess.
No, people don't use 99. People use 17. 17 will give you the default Boolean type.
Oh, okay. Okay.
But still is a integer anyway.
Yeah.
That's actually, I'm talking about this just because we want to overcome the hurdle of the compiler. So sometimes you don't get missed. Okay, when you have different compiler. Next one is literal. Literal, you actually need to know how the integer is written, floating point being written, and then how scientific notation being written. Okay, that's okay. That we don't cover too much. Constant character is okay. Character and the string. Okay, character and the string. String, we don't have the string type in C language. We do have array of characters. So array of characters and string in C language is almost the same. I would say almost means that they are one thing, but we will consider string to be a special type of array of characters. How to define it? String is an array of character ending with a 0 at the end. Okay, ending with a 0 at the end. So that's a difference between character and the string. Okay. So we do have a char type. That's a single character. Then we have the correct array type, character array type, and we also have the string type. But C doesn't have a string type. C's string is a special kind of array of characters. And you need to store the minus backslash 0 at the end to make it a string.
Yeah.
Okay. It's different from the array then. Let's try this. Let's try to give you an example on this. Let's call it string 0.c. So right here include stdio.h. So right here, we can actually declare a character A of n equals double quote. Let's go for A, B, C, D, E, F, G. The length need to be longer than the string. This is okay. Let's do print F. Okay, let's actually save and run right away. Okay, it's okay. Now we can also declare as vector B also 10. Let's all use a 3. It will be equal to, we can use each character. So you do A, B, C. But you do not have a \0. So this one is considered an array of character, but not a string. This one is considered to be an array of character, but it's not a string. A is a string. A, okay, A is a string. If you write it in that way. Let's try another one. Let's try character C of 4. Let's also do it with A, B, C. Then we have \0 right here. So this one, you have 4 character A, B, C, but come out with an ending of the \0. So this one is an array of characters. It is also a string. Okay, let's print it.
它的研究新很上，这个就是 Pacific。
Okay, so if you print out a C string, it will also work, okay? So C is a string, A is also a string, but B is not. So let's try to print B. B don't have ending of the percentage of the 0. So let's print B. B, if you are lucky, it may print a string. If you are not lucky, they will print a lot of garbage for you.
Okay.
Okay, you see, B is what? A, B, C, A, B, C. It has no ending because we only have 3 characters, but how comes it print 6? It is wrong. So I'll say that it print ABC because you store A with A, B, C, D, E, F, G. They come with ending 0. B with A, B, C, C with A, B, C, \0. So when you print B, it actually print the B and C together. Okay, so B is not an array of characters, it's not a string. C is. So C, if you ending with a \0, that's a special kind of array of characters and it's considered to be string. So in Java, in C language, there's no string. There's only array of character, and string is a special kind of array of characters.
Yeah.
That's what I want to say. And you need to know about the memory model, how the variable and the program being stored in the memory. Okay, you do have the instruction section that actually put your code in there. You do have data section, put your static variable in there. You do have the stack and heap. So this one, we just show you this right now. Later, we are going to talk about different, how to put the variable in here, here, and here. Okay, we'll cover it later. Okay, anyway, today I want to stop right here because we have one student missing. I don't want to go too far. Then she will not be able to catch up. Number two, you are outside. I don't think you can remember too much. So go back home and then study harder next time, okay?
Okay, all right. Sounds
Okay,
good.
see you next time. Bye-bye.
Thank you. Bye, Mr. Cho.
Bye-bye.